grab their seats? Make sure you grab a drink first. Welcome, everyone. My name is Lindsay Hirsch. I work for Solar One at the Mayor's Office of Sustainability, and I want to join Rachel in welcoming all of you tonight, both our viewers online and those of you who are here, to Clean Energy Connections. Does everyone know what Clean Energy Connections is? Can I get a yes from the crowd? Yes. Great enthusiasm, guys. So Clean Energy Connections, for those of you joining us for the first time, is an event series produced by Solar One, NYU Tandon's Urban Future Lab, and our partners at Green Tech Media. None of you fine folks would be here tonight if it weren't for our sponsors at NYSERDA, so thank you so much, NYSERDA. I know a few of you are in the room tonight. NYSERDA funds this event through its Clean Energy Communities program, which works with municipalities across the state to reduce energy consumption and greenhouse gas emissions. Just to throw in a few words about Solar One, for those of you who are unfamiliar, Solar One provides education and technical assistance to make New York City a more sustainable and resilient place to live and work. Solar One offers many services, including free technical assistance to affordable housing developments to help them go solar, works with hundreds of New York City public schools, provides outreach services to the New York City Retrofit Accelerator, and delivers a green workforce training program for jobs in the clean energy economy. Now, there's just a few housekeeping rules before the fun starts tonight. One, this is a discussion series, it's not a lecture. So if you have questions, please write them down on the index cards that were provided to you up front. We will collect them and then run them up to the moderator. Two, we are filming, we are live streaming this, so please try to keep the noise to a minimum. Please do not knock over your beer bottles and keep the foghorns to a 0. Three, last item, we all love getting free things. Especially tonight, we're lucky to get free alcohol. So let's show some of that love to the people handing us our beverages, and don't forget to tip the bartender. Now I'll hand it over to Rachel.
Thank you, Lindsay. My name is Rachel Fleischer. I'm the community manager at the Urban Future Lab out of NYU Tandon. We'd again like to give thanks to NYSERDA, who not only sponsored this event series, but they are also our sponsor of the Urban Future Lab, along with others such as Oric, BP, and Daikin. And also another shout out to Green Tech Media for hosting the live stream of this event. For those of you who don't know, the Urban Future Lab is an incubator created out of NYU School of Engineering. We find startups who have market-ready solutions to the climate change problem and facilitate their growth in order to make a real impact on the future of sustainability in the New York City area. Our main focuses are smart mobility, smart grid, and smart city. And we have incubated over 40 companies with a 92% survival rate, which is pretty good. Our keynote of this evening is going to be Loic Chapoz. About Loic, he leads the multifamily team for NYSERDA and focuses on building energy retrofits. Prior to his work with NYSERDA, Loic worked as an independent consultant on energy efficiency policies in France, as a fuel efficiency specialist in the airline industry, and as a commercial pilot for 10 years. I'm going to pass the mic over to Loic.
Thank you, and good evening, everyone. So my name is Loic Chapoz. I'm with NYSERDA, the New York State Energy Research and Development Authority. I feel like you've heard the name more than once tonight already. And I focus on energy efficiency in buildings, which is really what we're here to talk about tonight. I want to start by telling you a little bit about our shared vision, our shared goal for the state and the city of New York, which is reducing our greenhouse gas emissions by 80% by 2050. We have a few milestones on the way to help us get there to that big lofty goal. So our first milestone is reducing our our greenhouse gases, by 40% by 2030. So just in a few years. We are also aim to procure 50% of our electricity from renewable energy and save, this is our brand new energy efficiency goal released just a few weeks, save our 185 trillion BTUs by 2025, so just 7 years from today. And what it means, 185 trillion BTUs, it's enough energy to fuel and power 1.8 million homes across the state of New York, and it also gets us 1/3 of the way of our greenhouse gas emissions reduction objectives for 2030. But what those objectives really mean is that we have to change the way we produce our energy, and we have to change the way we consume our energy to get to those goals. So let's first talk a little bit about how we produce our energy. With today's grid, we utilize the grid about 54% of the time, meaning that 46% of the time on average, the different assets that's constituted to this grid are sitting here idle, doing nothing, just because the grid is designed and built for the hottest day of the summer in the state. And that's a big gap if we compare it to the mid-range of other industries that have been able to really make tremendous progress over the last couple of decades in terms of utilization rate, and they've been reaching the mid-80s range. So we're working to bridge that gap. So in today's grid, we have those big central power plants. We have large distribution lines and substations, and the electrons really flow one way from the power plants to the different buildings, residential buildings, commercial buildings, and universities and hospitals. We've made some progress over the last few years. We're started to install some solar power here and there. We're starting to see big plans around wind power as well. But clearly, we're not going to get to 50% of renewable electricity by 2030 if we continue to bolt on solar panels onto a grid that is really not designed to have a massive amount of renewable energy. So what we really need to do, and that's what we're doing with reforming the Energy Vision REV, is building the grid of tomorrow. So it's a grid that is integrating a larger amount of renewable energy production and decentralized energy with solar panels, with wind. It's a smarter grid where electrons are able to flow in different directions, where the consumers and the production assets are communicating with each other. And that's really the grid that we need to get to our goals of half of our production from renewable energy by 2030. So the way we produce energy is important, but the way we consume it is just as important, especially in dense urban environments like New York City. We have close to 1 million buildings in New York City, and that's really where most of the energy is consumed. So what it tells us is that we really need to change the way we consume our energy in buildings, and we really need to start implementing what we call deep energy retrofit. What it means is reducing our energy consumption by 40 to 70%, and really reducing our energy consumption, taking into account everything from how we heat our building, how we cool them, how we produce our hot water, especially for residential lighting, and all the plug loads, everything that we consume with our electronics. And those deep energy retrofits have really a number of benefits. It increases comfort both in residential and commercial building, increases productivity in commercial buildings. It has a great impact on health that are starting to be demonstrated in a sturdy way. One also very important point for New York, and especially New York City with hurricanes, is that it improves resiliency of our building stock. It also creates a number of jobs, and jobs that are qualified and that cannot be delocalized. But it's pretty hard today to do deep energy retrofit. The costs are pretty high. There's also this big issue that with our dense urban environment, we don't have that many empty buildings. So we cannot take a building, empty it out, relocate the tenants, do a bunch of work on those buildings for a year, and then ask the tenants to move back in. So really, we need new solutions so that we can achieve those deep energy retrofits with the residents in the building, with the commercial tenants in the building. It also needs to work with the capital improvement cycles of the different types of building that we have. Some buildings, like affordable housing buildings, they tend to do a lot of work at the same time, so it's relatively easy to do a one-time deep energy retrofit. For market rate buildings and for commercial buildings, it's a lot harder because those buildings are maintained over time. There is not that big need that comes together at the time of refinancing, for example, for affordable housing building. And another really big issue, big barrier today is the availability of all the products, all the material, all the systems we we need to bring down our energy consumption dramatically. So clearly, it's not easy. I want to take a quick pause and look at those two things. So you obviously recognize things that we all have in our homes or apartment: a front door, a refrigerator. The front door on the right costs about twice as much as the refrigerator. And when you think about it, it does a lot less. The refrigerator also has a door that is open probably more frequently than your front door. It keeps your food cool. It produces, this one is a fancy one that also produces cold water and ice cubes. So why does it cost so much less than a front door? And a big part of the answer is scale, is demand. The refrigerator manufacturer sells thousands and thousands of units every year. So they're able to really fine-tune the process to optimize the cost and sell it at a much better cost. The front door manufacturer doesn't sell that many doors every year. And so it's really hard to bring in automatization and really bring down the cost because the demand is not really there. And we're seeing kind of the same thing for high performance retrofit or deep energy retrofit. So this is an example of a retrofit where we're doing it this custom way, a little bit like a front door is a custom product. It takes a lot of time, it costs a lot of money, it's not very efficient. And now imagine if we could do it the refrigerator way. If we could automatize all that, if we could produce the products, the systems that we need to do our deep energy retrofit well needed in a factory in a way that is cost efficient, in a way that has a better quality control, and in a way that delivers performance in a way that is really reliable. We know what the end product is going to be, just like we know that our refrigerator is going to keep our food cold. Imagine that those products are easier to transport, easier to install in a building with the residents in place, without displacing the people who live in this building, without asking them to leave their home. And now imagine that we can do the same thing for mechanical system. It's a little bit hard to see on this one, but you have an energy recovery ventilation system, a hot water boiler, and a heater that are next to each other, and it takes a good amount of work and ingenuity to put that together in a home. Imagine we can also, for those products, basically bundle them together, produce them in a factory, and bring them on site in a way that is much easier to install and in a way that makes their performance a lot more predictable. So as I said a little bit earlier, part of the answer is scale. So in order to get those products, in order for the industry to produce and sell those products, we really need to demonstrate some scale in the market. And I think we can do that by combining demand for deep energy retrofit and new construction. The products that I have showed in the slides before, those are products that exist. They're available in the market in Europe, and they're applicable as much for new construction as for deep energy retrofits. So the good news is that we have examples in other places in the world of creating that market, creating that demand, and really pushing and leading the industry to create those products and deliver them at a much lower cost. Those buildings were retrofitted from 1970s level of inefficiency to net zero, meaning they produce as much energy as they consume over the course of the year, in just 1 week, with the residents staying in their home. And that's the result of a Dutch program called Energiesprong. This program has been expanded to the United Kingdom, Germany, and France. And we are starting this program in New York to really bring the demand and try to build that market in the state of New York as well, with a state program that we're calling Retrofit New York. How do we do that? First, we looked at the building stock that we have in New York. We cannot just import those products. We also need to make sure that those products and the market that we're building really serves the building in our climate zone. So we looked at the building stock in the state of New York, and we saw that most of our multifamily buildings are between 2 and 7 story high. So that's where we're focusing initially. And that's only part of the preparation work that we did to launch that Retrofit New York program. We also sent a consultant, a building scientist over there in the Netherlands, to look at the results, look how the products were installed, make sure that the residents were happy. And we talked to more than 100 people here on the ground, building owners, suppliers, architects, engineers in New York, to make sure that we would be able to be successful here. we've basically done with this preparation phase, and we're now launching our pilot project. So we released an RFP in February to select buildings, six affordable housing buildings of those two typologies that I just highlighted a little bit before. So 1 2-story garden style, 3 to 7-story building, really focusing on the most common building types. Also select highly qualified industry teams here on the ground in New York that can design, build, and install those new solutions. We'll then support them through a 6-month design period, and we're asking them to design and build solutions that are adaptable to similar building. The idea, again, is to go to scale. And we'll do it again. We don't think we'll fully get to net zero retrofits and to a cost that is low enough to have the market explode in New York in just one round. So we'll build a solution, we'll learn from them, and we'll improve them until we reach the tipping point and until the market takes off. Just to give you an idea of what the scale of the market can be here in New York, we're starting with affordable housing because that's where it's the easiest, to be quite frank. We have 1.7 million units of affordable housing just in the state of New York, not the Northeast, not the US, just the state of New York. If we think that half of them are going to be retrofitted over the next 20 years, that gives us 40,000 units per year. And that gives us an additional market, a new market on top of the current construction market of more than $1 billion every year. And to me, that's really what starts to prove the scale and prove the scale to the industry and create that deep energy retrofit market so that we can have the product that we need here in New York. Thank you. And so proving the market for deep energy retrofit in New York is really the topic of our panel tonight. And with that, I would like to introduce Ilana Judah, who is going to moderate the panel. Ilana is the principal and the director of sustainability at Ethixful. She's also, and more importantly, a leader in sustainability in the built environment. She's, for example, on the board of New York Passive House, and she's at the forefront of high efficiency buildings, not only as a practitioner, but also working with the city of New York, for example, on the right policies with the 80 by 50 working group, trying to get us there in terms of building energy efficiency and in building that market. Thank you.
Welcome, everybody. I'd like to bring up our panelists. We have a great panel tonight, and I think we'll have a really terrific conversation, hopefully, with all of you all as well. So first, I'd like to introduce Aaron Ardour, who's a senior policy advisor at the New York City Mayor's Office of Sustainability, focusing on retrofits. Next, Ryan Flynn, who's a performance construction manager at Mitsubishi Electric. And last but not least, Ken Levinson, who is the Chief Operating Officer of 475. And Loic will join us as well for the panel. So welcome, everybody. We're really excited to have a great conversation tonight. So first of all, I'd like to ask everybody, maybe we can just do a quick, starting with Aaron, introduction to your specific area of focus, how that ties into retrofits, and what your particular expertise is. And then we'll circle back with more detailed discussions.
Sure. Good evening, everybody, and thank you to NYSERDA and to everyone who's hosting us this evening. I'm Aaron Ordauer. I'm a senior policy advisor with the Mayor's Office of Sustainability here in New York City. I work with our buildings team, where we focus on strategies that are both policies and programs to support energy efficiency and clean energy use in our building stock of 1 million buildings here in the city. I specifically work with our signature technical assistance and support program, which is called the Retrofit Accelerator. Retrofit Accelerator is already helping more than 5,000 buildings around New York City reach energy efficiency goals. But I'm specifically working with colleagues on a high performance track of the retrofit accelerator. And this high performance track is really New York City's attempt to emulate a lot of what Loic talked about in his early remarks, doing long-term capital planning with building owners across building typologies to reach a level of deep energy retrofits, of deep energy savings, 40 to 60%, by our 2050 goals. Happy to talk more about that as we get into the discussion. Thank you.
Ryan?
Good evening, everybody. Ryan Flynn with Mitsubishi Electric. I play the role of Performance Construction Manager at Mitsubishi Electric, specifically focused on supporting builders, architects, and engineers in both new construction, but especially for tonight's purposes on retrofits and renovations. No two buildings are alike, so I assist folks with identifying what equipment is perhaps a best match for a specific building's needs in terms of heating and air conditioning loads so that we could create a comfortable, healthy, and energy efficient space.
Good evening. My name's Ken Levinson with 475 High Performance Building Supply. Actually, for many years, a practicing architect and came into this business and focused on retrofits, high performance retrofits, and the products around them by starting out by doing some passive house projects in Brooklyn, in historic landmark districts in 2009, 2010, and not finding the products or expertise in the supply chain that we were needing to make these buildings. And so out of a few of these retrofits, we started a company. We knew that there were products, companies, expertise doing this for 20 years in Europe. And so founded the company 475 High Performance Building Supply and formed these relationships with European suppliers to bring the products to market, but also to provide the education and help build the market. And really grew out of retrofit construction and focused to a large degree on it. It's now gone beyond that, and we're coast to coast across Canada. And I should add, we're proud alumni of the Urban Future Lab, located in Brooklyn. So glad to be growing. Good to be here.
And Loic, did you want to add anything else beyond your
I would just say
introduction?
that beyond the focusing on really deep energy retrofit and creating that market, we also try to help building owners to do what many people consider as deep energy retrofit, but we consider like normal retrofit. So helping building owners save 20, 25, 30% by doing more incremental changes to their building as well. So we're supporting building owners where they are in their capital improvement cycle.
Great. So I think we have a lot of diversity here tonight in terms of expertise on the policy side, architecture, HVAC, and so forth. And so I think that we'll have a really healthy conversation. I'd like to start perhaps with a little bit on the policy side, talking about the city's 80 by 50 goals and how those are incentivizing or what you see is in terms of successful incentivizing of energy retrofits, how that ties into the 80 by 50 goals. And for example, there was Intro 1745 that was introduced that will kind of come up for discussion hopefully soon related to retrofits. So I guess the first question is, well, how do you see the 80 by 50 and policy initiatives helping to drive this? But then the second question may be, well, what are some of the key barriers? There's obviously the sort of the synergies between policy and construction, but there can also be conflicts of, well, what the intention is versus the reality of the nuts and bolts of getting things done. So perhaps we can have a discussion a little bit about both sides of the coin.
Okay. Should I kick that one off?
Absolutely.
Okay, thank you. So as I'm sure many of you in the room know, New York City is committed to an 80% reduction in our greenhouse gas emissions, much like the state. When we look at energy use in New York City, buildings are responsible for roughly 70% of our greenhouse gas emissions. So getting to very deep energy retrofits and a very high building performance across our building stock of 1 million buildings is the only way that we can accomplish that goal of actually getting to 80 by 50. What that means is we have to really figure out what are those strategies and technical interventions to buildings that are feasible and that will actually get to that level of performance. Our office led an initiative called the Technical Working Group a couple years ago that really tried to answer that question and say, if we know that this needs to come out of buildings, what are the pathways, what are the strategies to actually get there? And so we published this, and it's, I encourage those of you that are passionate about this topic or working in the field to look at what the recommendations were out of the Technical Working Group, because we did actually show that it is possible through multiple pathways to reach a very deep a level of energy savings across New York City's most common building typologies. To reach 80 by 50, though, a big component of what we analyzed is that many buildings will have to go towards high-efficient electric heating and cooling, heat pumps for their domestic hot water, for their space heating, and for cooling. The deployment of those technologies has been limited to date in New York City. We think there's tremendous promise. It's the dominant way that buildings are heated and cooled in other parts of the world, notably in Asia, increasingly in Europe. There's people on the panel that I think can speak in more detail about that. But we're really interested in how to promote those kind of energy retrofits. To respond to the question about Intro 1745, this was the energy performance mandate that Mayor de Blasio called for last September, was introduced in council last November, and is currently being discussed in some version, being reintroduced shortly at City Council. We think this is essential. What this would require is that buildings meet a minimum standard of energy use. And it's not anything that's been done in any major city to date, really saying not for new construction, but for our existing buildings. And I should put in parentheses, we think 90% of our buildings that we have today are still going to be with us in 2050. For existing buildings, it's a requirement that they meet those buildings above 25,000 square feet meet an energy